Hello everyone.
Hello, good evening, sir.
Good evening. तो लास्ट क्लास में हमने डिग्री ऑफ रिडक्शन कवर किया था और आज हम इसी से आगे कंटिन्यू करेंगे। सो ये पार्ट हम डिस्कस कर चुके हैं फील्ड और ये प्रैक्टिस कर चुके हैं क्वेश्चंस। फील्ड भी हम डिस्कस कर चुके हैं आई थिंक लास्ट क्लास में।
Yes, sir.
This question after this. Yes. Now we are at theoretical oxygen demand, right? So what is theoretical oxygen demand? We want to know theoretically how much oxygen is required for 1 mole of substrate. Okay. So as per this equation, you can see if we have 1 mole of substrate, okay, this 1 mole of substrate, then how many moles of oxygen is required for this substrate is known as theoretical oxygen demand. Okay, and that we represent with which stoichiometric coefficient? Which stoichiometric coefficient represent? Yes, A. Okay, so A here is representing what is the theoretical oxygen demand as per this equation. Okay, so we have already discussed available electron balance equation, and you know that the equation is this, that the number of carbon atoms into degree of reduction, this is the available number of electrons in oxygen, then this one is the available number of electrons in which component?
Biomass.
Mass, and this one is for
Product.
So now in order to find what is the theoretical oxygen demand, we can also use this equation. Previously we have used historical elemental balance. Okay, by using elemental balance equation we find out the values of A, B, C, D and E, but here we will use electron balance equation in order to get our answer for theoretical oxygen demand. So we have to solve this equation for A, and so the answer will be equals to A equals to C, or you can write it as omega gamma S minus C gamma B and again minus F J gamma P divided by 4. Is this fine?
Yes, sir.
Yes, sir.
So by using this formula, we can find out theoretical oxygen demand. So there is no need to remember this, or you only need to learn this equation, because by learning this equation, you can form this equation. Okay, so like for biomass, you have to learn only this equation, ln xf by x naught equals to nu t. That we will discuss in batch culture lectures. So you only have to remember this equation. Likewise, you have to remember only this equation. You can find the value of C, you can find the value of F, you can also find the value of A by using this equation and making the formula for that particular stoichiometric coefficient. Okay. So as per theoretical oxygen demand, we have already discussed what is the available electron balance. After available electron balance, you will get this equation. Okay. Now there is one question from PM Doran book, and we are going to practice this question. So as per this question, you have this organism with this biomass formula is produced from glycerol. Glycerol formula is C3H8O3 in aerobic culture with ammonia as nitrogen source. The biomass contain 8% ash and 0.40 gram biomass is produced for each gram of glycerol consumed. No major metabolic products are formed. What is the oxygen requirement for the culture in mass terms? Okay. So you have to find the oxygen requirement. Okay. So for oxygen requirement, as we have discussed, first we need either you will do stoichiometry or we can say elemental balance. But for elemental balance, we need one equation for which will represent the relation between them. But as we don't have that equation, we will go with the electron balance equation. And the electron balance equation was omega gamma s minus 4a equals to number of carbon gamma b and plus for product is fj gamma, right? So this was our equation. So by using this, we can find the value for a. A will be equals to again omega gamma s minus within bracket c gamma b plus fj gamma b divided by 2. Okay. So now you have to tell what are the values that we need in order to find the value of a. Okay. So you can start with so start solving this question. I am giving you 2 minutes. So anyone have any idea how to solve this?
So first we have to write the equation for the.
After that,
After that, we have find out degree of reduction and
the degree of reduction and all this. So let's see. First, as per this equation, this we need to find what is the value of A because A is representing the moles of oxygen required. Okay, theoretical oxygen demand we can see. For this formula, what we need, first of all, we need value of W. What is the value of W?
3.
So the value of W is 3 because this glycerol is our substrate.
Substrate.
And for substrate W is 3. That is the number of carbon atoms in it. Then what is the degree of reduction of this? So degree of reduction you have to find.
So it will be 14.
Degree of reduction is 14.
सर हम लोग पूरा इलेक्ट्रॉन फाइंड आउट कर लेंगे उसमें कितना इलेक्ट्रॉन ट्रांसफर करेगा उस मॉलिक्यूल से.
You are telling the available number of electrons.
Yes sir.
40.
So that is 4 to the 12 plus 8
40.
minus 56. Okay. Good.
उसकी वैल्यू हो जाएगी सर ओमेगा और रिडक्शन सबस्ट्रेट की वैल्यू आ जाएगी.
So these are the 14 electron minus. After that, what do we need?
C gamma B.
Value of degree of reduction of biomass, which you can find with the help of this formula. Okay. So tell me what is the value of degree of reduction of biomass? Almost time. What is the degree of reduction of biomass?
So 4.23.
4.23. Good. So 4.23 is the degree of reduction of biomass. Okay, good. Then also we need the value of C, which is the stoichiometric coefficient of biomass, right? So in order to get, how we will get this value of C? Do we have some kind of information in the question which we can use to find the value of C? Read the question. There may be some kind of information which we can use to find the value of C. So I'm writing only C over here. Then plus, do we have any kind of product with
No,
us?
sir.
So as we don't have any product, so this will be 0. Okay, so this is the only part that we need to calculate the result. Okay. So in order to find the value of A, we need the value of C. What other information is given in the question that we haven't used till now?
So biomass ash and
And
0.40 gram biomass which is produced when each gram of glycerol is consumed.
so what is this value is representing? What does 0.40 value represent?
So 1 gram of glycerol will produce
Yield.
0.40 gram of
Yield of
biomass.
biomass with respect to substrate. Isn't 0.40 gram biomass produced per gram glycerol. So gram per gram is the unit of yield, right? That we have discussed yesterday. So it is 0.40 gram per gram. That means yield of biomass with respect to substrate, right?
Yes, sir.
So 0.40 gram biomass is produced per gram glycerol consumed. So we have also seen one formula for theoretical uh, yield, right? So the formula was y-axis equals to, what was the formula? C into molecular weight of cell divided by
Molecular weight of
weight of
substrate.
Molecular weight of
substrate,
Substrate.
right? So yield we have provided, that is 0.40 gram per gram equals to C. What is the molecular weight of cell? And what is the molecular weight of substrate? Calculate fast. You have given this formula. You need to find what is the molecular weight of this cell. So carbon 12 plus 1.75 plus oxygen having 16 into 0.43, then plus within bracket 14 into 0.22. So what value people are getting? Hello.
Yes, sir.
Yes, sir.
What is the molecular weight of cell?
2.71.
How much?
Sir, molecular weight of cell is 23.71.
23.71.
71.
Okay, so one is given 23.71. Everyone getting this value? Yes or no? Sergeant, are you getting this value?
So I have calculated the next one. Yeah, we calculated it.
So that is 92. Sir, the molecular weight of substrate.
What is 90?
Molecular weight of substrate 92.
Good. So 92 is the molecular weight of substrate,
Yes, sir.
and the molecular weight of cell you have calculated 23.71. But actually what happens, I have told you that when we find the molecular formula for the cell, what we do, we first uh, dehydrate the cell and then burn it so that gas, we can analyze the gas, and by analyzing gas we identify the composition of element, and what rest is the residual ash. Okay, so here they have shown that after burning it, we left with 8% ash. So this 8% ash is part of what? Cell only, right?
Yes, sir.
Okay. So this formula that you are, this mass you are getting is the mass of that gases composition. Okay. In order to get the actual mass of the cell, we also have to consider this 8% residual ash.
8%
Okay.
ash.
Now this 8% residual ash is, uh, if this is 8%, then what percentage is this mass showing? 23.71. If 8% left in the Petri plate, then what is the composition of the mass? What is the percentage of the mass that we have analyzed? 92%, right? So
Yes,
this
sir.
is the 92% mass of the cell. Okay, 23.71 is the 92% mass. But in order to get the 100%, what we will do? 23.71 divided by 92 into 100, right?
Yes, sir.
Okay, because 8% left in the plates, so that means this as 8%. uh, so that means only 92% we have analyzed. So 92% is the mass that is coming from this formula. So we also have to add this 8%. Okay, in order to do that, what we will do, first we divide it with 92 in order to get what is the mass of 1%, and then multiply it with 100 in
Yes,
order to
sir.
get 100% mass. So what is the value?
So 25.77.
25.77, okay, gram, or Dalton you can say. Okay, so that is the mass of the molecular, or you can say molecular weight of cell. Okay, so now use this value over here. Molecular weight of cell is 25.78, you can use. Now we have everything. We have yield, value of yield, we have molecular weight of cell, and we have molecular weight of substrate. So I have chosen this question just to tell you about this residual ash. In case if they ask some question which include this residual, so you can do this by adding the mass to the molecular weight, to the mass which you have calculated with this formula. Okay, now what will be the value you will get from this? C equals to
1.42.
1.42. Everyone getting this value? See, remember, whenever you calculate in exam, okay, always try to find the answer after 3 decimal places, till 3 decimal places. Okay. So you have calculated till 2 decimal place. Try to add one more digit. Okay.
1.427.
So that will be 0.40. 1.427. Okay. Now you have everything. 14 minus 4.23 multiply 1.427 divided by 4. Now tell me what will be the final answer for this. Calculate fast and tell me the answer up to 3 decimal places.
7.4 divided by, so 1.991.
1.991. Okay. So this is the value of A. A is the stoichiometric coefficient of oxygen. Now, after this, if we want to find out what is the oxygen requirement of this culture in mass terms, so we need to find out in grams. Okay. So you have to tell the answer in units gram per grams, means how many grams of oxygen is required per gram of glycerol. Okay. So that will be in mass terms. That for because this value, what this value is showing, that for 1 mole of glycerol, this many moles of oxygen is required. Now we want to find out in mass term that how many grams of oxygen is required for 1 gram of glycerol. That means you want to find out the yield of oxygen required per gram glycerol. Clear? So try to find out that. So that means YO2 glycerol you have to find out. So moles of oxygen required, what will the oxygen? A into molecular weight of oxygen, right? Divided by molecular weight of glycerol. As we have only 1 mole of glycerol. So moles multiply molecular weight. Moles multiply molecular weight. That is the simple logic to calculate yield. Simply multiply mole with the molecular weight and divide those values. So what will the value that you will get from here? 1.991 into what is the molecular weight of oxygen? 32 divided by what is the molecular weight of glycerol? 92. So what will be the answer? What will be the answer? Calculate fast.
0.69.
0.692.
0.692 and unit will be gram per gram
Gram per gram.
glycerol.
Gram per gram. Yes, sir.
Okay. So this is the value that this question wants you to answer. Okay. So this is how you will solve this type of question if it comes in GATE exam. Okay. So till now there is no question that have asked for oxygen requirement. So सबको clear हो गया?
Yes, sir.
Yes, sir.
Okay. The next concept is of maximum possible yield. Okay. So now you have to find what is the maximum possible yield. So before that we have seen observed yield, then we have seen theoretical yield. Now we have maximum possible yield. So in maximum possible yield, what happens that we want to find out that if we provide 1 mole of this substrate, 1 mole of our substrate, then what will be the maximum biomass that we can generate from this substrate, or what will the maximum product that we can form from this substrate. So when they ask such type of question, that means they want us to calculate maximum possibility. So how can we calculate maximum possibility? For that, again, we have to write our electron balance equation. And electron balance equation, you know that omega degree of reduction of S minus 4A equals to C into degree of reduction of biomass plus Fj degree of reduction of product, right? So try to write this equation again and again in order to learn this. Now, if we take this minus 4A on the right hand side, then the equation will become 4A plus C gamma B plus Fj gamma B. Okay. Now this equation, what this equation is showing us that if you have these many numbers of electrons available in the substrate, so these are the available electrons in the substrate, then these available electrons will be divided to some part of the electrons will go to this oxygen. Okay. Some fraction will go to biomass and some fraction will go to product. Okay. So which compound will synthesize more will depend on how many electrons from the substrate is transferred to that particular compound. Okay. So these are the total available electrons and what fraction is transferred to that compound on which the synthesis will depend on. Okay. So the total available electrons will be transferred to, some part will be transferred to oxygen, some part will be transferred to biomass, and some part will be transferred to product. Okay. Now, if we want to calculate what will be the maximum possible yield of biomass, okay, in that case, where should the electrons of the substrate should go?
Biomass.
Biomass. Okay, that means we want all the electrons from this substrate to be transferred to biomass only. Okay, if all electrons were transferred to biomass only, then the concentration that we will achieve of the biomass will be maximum. The yield we will get is maximum. Similarly, if we want our product to be synthesized, okay, so in that case, all the electrons should be transferred to the product. Similarly, for the oxygen consumption, okay, so here the electron will be transferred to oxygen. So dividing this equation, okay, so these are the electrons that is transferred to product. These are the electrons that is transferred to barium. These are the electrons that is transferred to oxygen. If you want to find out the fraction, what we will do? We will divide this with total electrons. What is the total electrons?
W gamma S.
Omega gamma.
Omega.
Okay. So omega gamma S divided by omega gamma S equals to 4A divided by omega gamma S plus C gamma B divided by omega gamma S plus Fj divided by omega gamma S. So this will be equals to 1. Okay. And you know that the total fraction is always 1. So out of 1 electrons, okay, this is the fraction of the electron transferred to oxygen. This is the fraction of the electrons transferred to biomass, and this is the fraction transferred to product. Okay. but you only have to remember this equation or this. You can either learn this or this. Okay. No need to remember this equation. You can form this equation. Clear? Any doubt?
No, sir.
Okay. So as per this formula of biomass yield, so yield is equals to C molecular weight of biomass divided by molecular weight of substrate. Okay. Now, in order to find the value of maximum possible yield, we need to find what is the maximum value of C. That means we need to find C max. Okay. So normally theoretical yield is representing that if you have 1 mole of substrate, then this substrate will transfer its electrons to biomass, then C moles of biomass will produce. When it will transfer some fraction of electrons to product, then F moles of product will be produced. But as you want to find out maximum possibility, then that means you want to find out what is the maximum value of this C. Okay, when all the electrons on the substrate will be transferred to biomass only. Is this clear?
Yes, sir.
Yes, sir.
Similarly for product. Okay, when we here we have to find out what is the maximum value of F. So how we will get the maximum value of C max and F max? For that we will use this equation. Okay, again the available electron equation we will use. So if you want to find out what will be the maximum value of C. So when will be the C will be the maximum? When all the electrons from the substrate will be transferred to.
Biomass.
So in that case, what will be the value of minus 4A?
So उसको zero ले लेंगे.
0. Okay. And what will the value of product?
Zero.
0. Because we want all the electrons available in the substrate to be transferred to substrate. That means no product or no oxygen will be, no electron will be transferred to oxygen or product. Okay. So in that case, we will have us with the equation omega gamma s equals to C gamma, right?
Yes, sir.
So here what this C is representing, this is C max, maximum value of C max, because what we have did, we made 4A 0 and this product electrons also equals to 0. Okay. So by this is the value of C max. So C max equals to omega gamma s divided by gamma. So when we will use this value of C max over here, then the formula will be for maximum possible yield. Any doubt?
No, sir.
No, sir.
Similarly, we can find out the maximum value of X. How we will do that? We will again use this equation, make other terms 0. We will left with us F J gamma P. So F max will be equals to omega gamma s divided by J gamma P. So this is the value of F max. Okay. And when we will use F max in order to find out the product yield that will represent maximum possible yield of product. Clear?
Yes, sir.
Yes, sir.
So
Yes,
this is
sir.
how you will find out maximum possibility. First, you need to find out the value of C max, and then you will have to find out the value of F max. After finding those values, we will use the normal theoretical yield formula, but with these values, and that will give you maximum possibility. So your formula will become y-axis equals to C max molecular weight of biomass divided by molecular weight of substrate, and for product it will become F max molecular weight of product divided by molecular weight of substrate. Okay, and C max and F max formula are shown here, but there is no need to remember these two formula. You have to remember only available electron balance equation. Okay.
Yes.
Yes, sir.
From that, we will derive these two formula, because otherwise we will have so many formulas to learn. Better we will remember only main formula. That will be easy. Okay, so this is the question from last year, GATE 2020, or sorry, last year, GATE 2021, question number 55. A bacterium produces acetic acid from ethanol as per the following reaction. The thermodynamic maximum yield. So here they are asking for maximum yield of acetic acid from ethanol. Okay. So as you know that acetic acid is what? Substrate. And ethanol is the substrate. Ethanol is the substrate and acetic acid is the product. Substrate. That means they are asking for YES, right? Yield of product with respect to substrate. Clear?
Substrate.
And as they are asking for maximum yield, that means we have to use value of F max. F max into molecular weight of product divided by molecular weight of substrate. So as we know that what is the molecular weight of product? Product is acetic acid. Find out what is the value of molecular weight of acetic acid.
60.
60. And what is the molecular weight of ethanol?
46.
46.
46. Now we need this value of F max because they are asking for maximum.
It will be
So what we
120.
will do?
Hello, sir.
Yes. Yes.
Sir, 60 एक मोल के लिए, sir.
60. For 1 mole. Yeah, that is fine. See,
Sir, वहाँ पे
here
2 मोल है ना, sir.
they have, so we can divide it with 2.
Okay, sir. Okay.
The equation will become for 1. Okay, substrate. You have to always take substrate as 1 mole. That you have to remember. Okay. So here they have given you 2 moles, but because by dividing it with 2, you can convert them to 1 mole. Okay. So always take substrate 1. Okay. So after that, we need to find out the value of F max. Okay. So how we'll find out value of F max? For that, we need available electron balance equation. What is that equation? Can anyone tell? Omega gamma S
Gamma S divided by J gamma P.
4A plus gamma B plus Fj gamma P. Okay. This equation you have to remember. After this, as we have no biomass production and we want to find out a maximum value of max. So in that case, we'll make these two values 0, oxygen and biomass. We will left with omega gamma S equals to Fj gamma P. And from here, we will get the formula of F max. F max equals to omega gamma S divided by J gamma P. Okay. Now, what is the value of W? Or you can, yes, 1. No,
one.
not 1. It's 2. In ethanol, there is 2 carbon, C2H5. So always use condensed formula. This is not condensed formula. First you have to condense it. C2H6O. This is the condensed formula. So what are the, so 2 is the carbon, and what is the degree of reduction of this? Or you can simply tell us the available electrons.
Sir, it is 24.
So 24 is the available electrons divided by available electrons in the product. What will be the available electrons in this product?
8
4 to 8. So 8 is for
8 for one
carbon
molecule of
plus
acetic acid.
4 and
One more of
minus 4. So that is 8, right? 8 you are getting. So everyone getting this value?
yes sir.
So divide this. What will be the final answer?
3.
I think this value is 12, not 24. This is not 24. This is 12. Available electrons in ethanol. Carbon is 2, so that will be 8 plus 6 minus 2. So available electrons will be 12, not 24. So that is 12 by 8. So what will be equals to 12 by 8 equals to 1.5. Okay. So 1.5 into 60 by 46. That will be equals to are you people solving, right?
1.956.
1.956.
1.956.
56.
So this is the maximum possible yield rounded off to 2 decimal places. So 2 decimal place, you can round it off.
196.
So anyone having any doubt related to this question?
No sir.
So this is how you will find out maximum possible yield. Okay. Then there is one question from PM Doran. Okay, we will practice this question also. The chemical reaction equation for respiration of glucose is this. The Candida utilis cells convert glucose to CO2 water and during growth, the cell composition is this plus 5% residual ash. The yield of biomass from the substrate is 0.5 gram per gram. Ammonia is used as a nitrogen source. What is the oxygen demand with growth compared to that without? Okay. So first you have to use the same method that you have used for previous exercise question in order to find the oxygen demand. Okay. So for oxygen demand, you need to find the value of E. So E will be equals to omega gamma S minus within bracket C gamma B plus Fj gamma P divided by
4.
4. So this will be the formula for oxygen demand. For that, you need the values of W. What is W? What is the value
So
of
one.
W? 6. Number of carbon atom in substrate. W represent number of carbon atom in substrate. That is
सर हम
6.
लोग डायरेक्टली तो निकाल सकते हैं सर.
You can also directly भी find out कर सकते हैं. Last time तुमने गलत बताया था.
क्या सर?
Last time तुमने 24 बताया था. इथेनॉल का.
सर वो 2 मोल्स के लिए था सर.
अच्छा. देखो जो लास्ट क्वेश्चन है उसमें जब भी हमसे मैक्सिमम पॉसिबल यील्ड पूछेगा so there is no need of the equation. Okay.
Okay.
Because the value of Cmax does not depend on the value of other stoichiometric coefficient. Okay. तो उस केस में आप डायरेक्टली फाइंड आउट कर सकते हैं, उसमें इक्वेशन को देखने की जरूरत नहीं क्योंकि वहां पर एफ मैक्स जो है वो अलग मेथड से आएगा, बट थ्योरेटिकल यील्ड में आपको देखना पड़ेगा उसकी वैल्यू. Okay. So what is the available electrons in glucose? So W gamma S is representing available electrons in glucose. How much it is?
24.
24. Okay. Then minus, then available electrons in biomass. But for that we need value of C, which is not given here. Okay. So what we will do in order to find out the value of C? Is there any information in the question which we can use?
Yes, sir.
5%.
The 0.5 gram per gram yield is given.
0.5.
Yield of biomass with respect to substrate is given, that is 0.5 gram per gram, and that is equals to C
P
into
molecule.
molecular weight of biomass divided by molecular weight of
Substrate.
substrate. So what is the value of biomass, molecular weight of biomass? First we will use this formula, chemical formula, to find the biomass molecular weight. Then you will add this residual mass. Okay. So what is the molecular weight you are getting from this? 12 plus 1.84 plus 16 into 0.55.
26.77.
26.77.
Yes, 5% HTP add करकर.
Okay, add convert. Good. So 25.44 is the molecular weight that you are getting from this.
Out H.
Now you have to add 5%. So that means this is representing how much?
95%.
95%. But we need to find for 100%. So divide it with
26.77.
95 into 100, 26.77. So this will be the molecular weight of biomass. So C into 26.778 divided by molecular weight of substrate. What is the molecular weight of substrate? 180. Because
Yes.
this is glucose. So what will be the value of C? C equals to 180 into 0.5, that will be 90, divided by 26.778 will be equals to how much?
3.36.
3.36.
Yes, sir.
Okay. So now you have the value of C. So we can write 3.36. The next thing of reduction of biomass. Find out the degree of reduction of this. Carbon 4 1.84 plus minus 2 into 0.55 and plus minus 3 into 0.2. Why we have taken minus 3?
Ammonia as a nitrogen source.
Ammonia is
Because
nitrogen.
ammonia is used. So reference is ammonia. So what will be the value? Plus 24 plus what is the degree of reduction? कितना टाइम लगेगा बताने के लिए?
13.91.
Degree of reduction. Degree of reduction of biomass. Nitin,
Yes, sir.
are you there? Degree of what is the degree of reduction?
The number of electron in the
No,
biomass by
value. Degree of reduction of biomass. काजल
4.14.
तो बताइए ना ऐसे कैसे आगे बढ़ेंगे. So do we have any product with us? Okay. Is there any product? Okay.
No,
So
sir.
that will be
No, sir.
so divided by 4. What will be the value of A? A will be equals to
So 2.725.
2.75.
2.52.
Second. 2.52. So this is your value of A oxygen demand. Okay. Now in the next part, they're asking C utility is also able to grow using ethanol. Here they want to compare, but we will not compare this. Okay, we only find the oxygen demand. C utility is also able to grow using ethanol as a substrate, producing cell of the same composition as above on the mass basis. How does the maximum possible biomass yield from ethanol compare with maximum possible yield from glucose? So here now they want you to compare what will be the maximum yield of this biomass when glucose is used as a substrate and when the ethanol is used as a substrate. Okay. So formula will be same y xs equals to C max within bracket molecular weight of biomass divided by molecular weight of substrate. Okay, start with glucose. First for glucose. So what will be the value for glucose? Maximum. For that we need Cmax, and you know the equation omega gamma s minus 4a equals to C gamma b plus Fj gamma p. So we don't have any product formation over here, so this will be 0 and this will be 0. So Cmax equals to omega gamma s divided by gamma b. So now put the value for glucose. What is the value of glucose for W? W will be, so
6.
you can calculate available electrons. Available electrons in glucose is 24 divided by degree of reduction of biomass that we have already calculated 4.4.
4.4.
Okay. So 24 divided by 4.14 is how, what will the value of Cmax?
5.44.
How you are getting 5.44?
5.797.
So 5.797.
5.797.
So 5.797, then molecular weight of biomass. What is the molecular weight of biomass that you have to find? Find out what is the molecular weight of biomass for this. So
26.778 हम लोग कैलकुलेट किया था ना पहले. फर्स्ट वाले क्वेश्चन
26.77.
26.77.
Yes,
सर फर्स्ट क्वेश्चन में हम लोगों ने कैलकुलेट किया था मॉलिक्यूलर वेट ऑफ बायोमास.
bio.
Okay.
26.7.
Was there the same equation? So
Sir.
what is the degree of that? What do we need? Molecular weight of substrate, which is 180. So what will be the value of y-axis?
0.86.
0.86 gram per. Similarly, you have to find out for ethanol. Try to find out this by yourself. What is the y-axis for ethanol? Ethanol formula, you know, C2H6O.
So C max is 2.89.
2.89. 2.89.
What is the y-axis?
So 1.68.
1.68. Everyone getting the same value? Try to calculate. सभी लोग कैलकुलेट करके चेक कीजिए सेम आ रहा है सबका. मैंने कैलकुलेट नहीं किया तो इसलिए मुझे आंसर नहीं पता है. आप लोग अपना आंसर कैलकुलेट करके एक बार चेक कीजिए सबका आंसर क्या है. पहले सबने कैलकुलेट. तो काजल,
तो थोड़ा डिफरेंट आ रहा है.
व्हाट हैपन?
तो डिफरेंट आ रहा है.
डिफरेंट है. कितना डिफरेंट आ रहा है बताइए.
0.977 मतलब 0.98.
चलो बता. सबसे पहले तो सी मैक्स की वैल्यू सबकी सेम आ रही है 2.89.
Yes sir, 2.9.
So Cmax, okay, 2.9. That's a 2.9. Then you have to find y-axis. Y-axis equals to Cmax, then molecular weight of biomass divided by molecular weight of substrate, which
Substrate.
is ethanol. So
Yeah.
value of Cmax you have calculated 2.9.
2.89 or 9.
Then molecular weight of biomass is
26.77.
26.77. And then molecular weight of substrate ethanol. What is the molecular weight of?
46.
So 2.9 into 26.77 divided by 46 equals to 1.68. आपने कैलकुलेशन मिस्टेक किया, चेक करो एक बार. देखो आंसर 1.68 आना चाहिए. बाकी सबका आ रहा है ना 1.68.
Yes, sir.
1.68.
So this is how you will find out maximum value of biomass, right? Or maximum yield of biomass. There is one question that we skipped. Check the question. Give me a second. Maximum biomass concentration. Slide number 15. Okay. Now try to solve this question. A microorganism is grown in batch culture using glucose as a carbon source. Then
सर कर लिया था ये
Apparent-
कल क्वेश्चन.
ये हो चुका है.
यस सर.
Which account of
ये कल हो गया था.
Okay, हाँ ये आपने कह दिया. So maybe that one is the best. Is that was the question?
नहीं ये नहीं हुआ था सर.
No, is-
Yes,
I think this one is the question. Yes, maximum yield. So you have to find out maximum yield for microbial conversion of glucose to ethanol on a mole by mole basis. You only have to find out what will be the value of here, because ethanol is the product. So at max you have to find out, because they want us to tell them more on mole by mole basis, not gram by gram basis. And you know that we always take substrate as 1 mole, right?
yes.
So you only have to calculate F max. So F max will be equals to C. Sorry. What will be the equation for F max?
W by gamma x upon J gamma P.
Omega gamma S divided by J gamma. So that means you need available electrons in substrate and available electrons in product. So how many electrons are available in substrate? Substrate is glucose, that is 24.
24.
And then what is the available
The
electrons in
answer will be
product?
2. Option B.
The 2.
So here it will be 12, 12 by 24, 24 by 12 is 2. Okay.
Yes.
So this was the last question from maximum yield. We have completed this topic. Done. So this is it. The next class we will continue with growth hormones. Okay. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.